Hello students, welcome to your Chapter 8 review video. In this video we're just going to briefly revisit the sections of Chapter 8 that we've looked at. I'm going to talk through some examples from each section, and hopefully this will inform your studying and will help you to sort of see the things that don't make sense to you, and then you'll have an opportunity to ask questions before we have to take a test. So in Chapter 8, we've been talking about functions, and particularly like equations with two different variables. And we started our discussion at the beginning of Chapter 8 by talking about relations. Okay, and relations took certain input values, which we called the domain, and certain output values, which we called the range, and sort of matched those up, right? So we created things called mapping diagrams. Those were, ovals, this, one for the domain and one for the range, and we had numbers in there and we had numbers in here, right? And then we would match them up, right? We would match an input value with an output value, or a domain value with a range value, right? We made lists of domain values, range values. Remember, it's important to remember, some of us sort of struggle with this. We do not list the repeats. Okay, don't list the repeats in the domain and the range. We also looked at relations on a graph, right? So we plotted coordinate points from whatever list we had. And then we talked about how a relation is or is not a function, right? So ways that we talked about relations not being functions would be if we had repeats in the domain values that had different range values, right? Repeats in the x that had different y values. In a mapping diagram, that looked like, one value of the domain having two arrows coming off of it, right? Multiple arrows going to different range values. On a graph, that looked like a vertical line on the graph hitting more than one point. So remember, we had the thing called the vertical line test. And if it hit more than one point when we drew a vertical line on that graph, then we would say it's not a function. Okay, so go back and review, refresh, determining if a relation is a function, how we represent relations in mapping diagrams or on graphs as well. Okay. In the second section of Chapter 8, we started talking about equations. Okay, equations that relate x and y, where x and y are just variables that we can put in any values we want. For x as an input or domain, y as an output or range. And the first thing that we did in this section was we just took coordinate points like 3, -5, for example, and we checked to see if it was a solution to this equation. Right, so we would plug the value of x and the value of y in, and we would do the math on both sides and see if it works out. So in this case, it would say -5 is equal to 2 times 3 minus 8. 2 times 3 is 6. 6 minus 8 is -2. -2, last time I checked, is not the same as -5, right? So we would say, no, this particular point is not a solution to this equation, right? So that was the first thing that we did in section 8.2. Take a coordinate point, plug it in, and see if it works, if it is actually a solution to that equation that you're given. We also then looked at linear equations and made graphs of them ourselves by creating tables of values, right? So we had an equation like, we'll just use the same one, 2x minus 8, and we made a table of values by just choosing some random x values. I did tell you that I want you to try to use these five x values as a general rule unless you have a reason to do something else. So -2, -1, 0, 1, and 2. We plug those values of x into the equation and we do math, right? And we do math to find the y values. The x's we get to choose, the y's we have to actually find. So this becomes -4 minus 8, right, would make -12 here. -2 minus 8. If I put -1 in there, 2 times -1 is -2, minus 8 is -10. If I put 0 in there, it becomes 0 minus 8 is -8. If I put 1 in there, it's 2 minus 8, which is -6, and this is -4. Right, so we make a table of values, and each of these x and y pairs is then a coordinate point on our graph, right, on our coordinate grid. So we would make ourselves a coordinate grid. We would have -2 in the x. We'd go all the way down to -12 in the y and put a point. At -1, we would be at -10. At 0, we would be at -8. At 1, we'd be at -6, -4, right? And we would make this graph here. Right, so that's what allows us to graph these equations. We pick x values for our domain, for our input. We use the equation then to do math, find our output values, okay? So that's sort of the second section. Does a coordinate point work in this equation? And take this equation and make a table of values, put it on a graph, all right? The third section was about finding intercepts on a graph. And remember that the intercepts really means where the graph, or where the line, the straight line graph, crosses over the x and y axes, right? The vertical and horizontal axes. So if we have an equation like, well, let's even do one with a fraction in it just for fun. Something like this. Okay, something like that. We can find both of the intercept points. We find a point x equals some value where we cross the x-axis. We find a point y equals some value where we cross the y-axis, okay? Now, some of you, it looked like, sort of discovered the coordinate point way to write those, right? So the x-intercept, x equals whatever, we would write as, you know, some number, question mark, comma, 0 on the y. And then the y-intercept, we would write as 0 for x, comma, whatever the y value is. Okay, so it's okay to do that as well. In this particular example, or, well, I guess in any example, if we were being asked to find the intercepts of a graph, if we are trying to find the x-intercept, right? So I'll just write over here, to find x, make y 0. Make y 0. So if I do that in this equation, if the y is 0, right, then this would say 2 times 0. 2 times 0 is 0. So my equation would just say 1/2 x is equal to 2, right? Because 2 times 0 is nothing. So it just goes away, it just totally disappears. And then I can divide away the half, divide by a half, and I get x equals 4. So x equals 4 is my x-intercept. And I found that x-intercept by replacing the y variable with 0, okay? To find the y-intercept, then we make the x 0. So we'd put 0 in here, we'd do a half times 0. 1/2 times 0 would be 0. So then the equation would say 0 plus 2y is equal to 2, right? But the 0 and the plus don't really matter. They can just go away because 0 plus 2y is just 2y. And then we can do a little bit of math, divide away the 2, and y is equal to whatever 2 divided by 2 is, and in that case it's 1, right? So y equals 1 is my y-intercept, and those come, like I said, from making the variable 0. Plug 0 in for y, you find the x. Plug 0 in for x, you find the y. Once you have the two intercepts, then we can plot them on a graph, right? So 1 on my y-axis would be up 1 right here. And 4 on my x-axis would be somewhere out there. Once I have those 2 points plotted on my vertical and horizontal axis, I can connect them and I will have my line. Okay, so I connect those, that's my line. All right, so that was section A3, finding the intercepts and then also putting those intercepts onto a graph. Okay, and then our last section section 8.4, we talked about the slope. Okay, and we had 2 videos on the slope. We talked about finding slope from coordinate points. Remember that slope is m, and we subtract our 2 y coordinates and subtract 2 x coordinates, and that makes a slope fraction, right? So it comes from, you know, something like 2, 6, -1, 4, right? So I can do 4 minus 6 because this is y2 and this is x2 and this is y1 and this is x1. 4 minus 6 over -1 minus 2. I end up with -2 over -3. The negative signs can cancel out and my slope would be 2/3. Right, so this formula is super, super important. It needs to be in your notes. You need to be familiar with it. Anytime, as long as we can get 2 coordinate points, we can always find the slope. So remember, we also found a couple coordinate points from a graph, right? We looked at the graph of a line and we sort of picked out, here's a point and here's a point. Use those coordinate points to do the slope formula. If we have an equation, right, y equals 1/2 x plus 4, we can do the exact same thing, right? We talked about plugging 0 in and plugging 1 in there, right? But you can pick any 2 x values you want, create 2 coordinate points like I have over here, right? Like over here. And once we have 2 coordinate points, we can use our slope formula, okay? If you have any questions about any of these sections, anything that you don't remember or never really understood, please reach out to me, send me an email, or give me a call. And I'd be happy to help. I'd be happy to explain or walk you through some examples before we take our quiz. Otherwise, good luck on the test, and we'll talk to you soon.